Okay, so we're going to start out with example 7 for 4.3. Use trig identities to transform one side of the equation into the other with theta between 0 and pi over 2. So that just means we're working with that nice positive side of the quadrant, or in the quadrant. So we don't really do anything with this. They're just saying we're restricted to this region right here. So it says use trig identities to transform one side into the other. And you're always going to kind of start with the most complicated side. So let's see what we know about these two. So we're using one of our, what did we decide? There were 6, 7, 8, 9, 10, 11. Using one of our 11. Well, I know that cosine is 1 over secant because that's one of my reciprocal identities. So I'm going to replace this cosine with what it equals. So in place of cosine, I put 1 over secant theta, and I'm going to go ahead and bring that down. So it's times secant theta, and I'm making that secant a fraction. And look, you have a secant on the top and a secant on the bottom multiplied together. These divide out, and you're left with 1. And that's what we're trying to get. You just transformed the left side into the right, and you're done. B part, they're not always quite that quick. We have secant theta plus tangent theta times secant theta minus tangent theta. Equal to 1. So we're going to transform the left side, because it's most complicated, into the right side. Well, our algebra brains probably are firing right now and saying, hey, you're multiplying two binomials together. Why don't you FOIL? And you might realize that these two binomials are conjugates of each other. When that happens, you just do first times first minus last times last, because your outer and your inner cancel. So I so far have a secant squared theta, a tangent squared theta, and a 1. I'm looking for a trig identity that has all of those parts or some of those parts. And I am drawn to this Pythagorean identity that says 1 plus tangent squared theta equals secant squared theta. That actually has all the pieces I need. I need to go over to the side and work with this, rewrite it, to try to make it equal that. Well, if I subtract tangent squared from both sides, it's gone on this side, and I get 1 equals. These are not like terms. I just write it down. And looky there. That's exactly what I'm looking for. So secant squared theta minus tangent squared theta is 1. And that's what we were trying to get. That's a little bit challenging. It's a little bit of work and puzzling to do. So the other thing I want to talk to you about is this idea of angles of elevation and angles of depression. So I'm going to copy this right here, and we'll just talk about it real fast. So sometimes we have to solve right triangles, and sometimes we have to draw problems from word problems. So they are just reminding you of something from geometry. If you have someone and they're looking up maybe at a bird in the sky, the angle from the person to the bird, and it's always from the horizontal. You always start at the horizontal. Well, the horizontal that connects this line is the horizontal that goes up. That's the angle of elevation. Or if you have a person and they're like looking down in the water and they see a fish, then you always start at the horizontal, no matter which way you're looking. So horizontal down to that line that connects the person to the fish. That's the angle of depression. So we will use this idea, and angle of elevation and the angle of depression in the same problem are equal to each other because of parallel lines. We might see that in just a second. Example 8, right from the book. A surveyor is standing 50 feet from the base of a large tree. The surveyor is standing 50 feet from the base of this tree. The surveyor measures the angle of elevation to the top of the tree. So from the person up to the top of the tree, from the horizontal up. So that's this angle right here. They measured that angle to be 71.5 degrees. How tall is the tree? So if you now remove the person in the tree from the picture, you just see a right triangle. And you've got the hypotenuse, which is not a part of it. This is our angle. So x is our opposite. 50 is our adjacent. That's tangent. So tangent of 71.5 is the opposite over the adjacent. I cross multiply, and I get 50 times the tangent of 71.5 equals x. Make sure you're in degree mode and work that out, and you should get 149.4 feet approximately for x. All right, last one. You are 200 yards from a river. So you are 200 yards from a river. We measure distance with the perpendicular distance. So you're here. Rather than walking directly to the river, so rather than walking this way, you walk 400 yards along a straight path to the river's edge. So you're going to walk on a straight path from here to the edge of the river. You're walking here. So it said it didn't want you to just walk straight there, but it wanted you to turn and kind of walk 400 yards that way. And there is a picture in the book. Find the acute angle theta between this path and the river's edge. Well, this was our path. There's the river's edge. So we're looking for that theta right there. This is my hypotenuse. And for our theta, this is opposite. This is adjacent. We're dealing with O and H, which is sine. 200 over 400 is a half. And you can look on your unit circle to find the theta that has a sine value of a half. So you're looking for the y values that are a half. And you should get pi over 6, or 30 degrees. And it said find the acute angle theta between that. So that's how I know that I'm only looking in this quadrant, because these are the angles between 0 and 90. This is where my acute angles are.